Okay, Nana, let's move on to question number 2. A manager has 4 subordinates and 4 tasks. The subordinates differ in efficiency. His estimate of the production each would do is given in the table. How the task should be allocated one to one man so that the total production is maximized is the question. So you can see the matrix over here. You got subordinates and you have task. Okay, the point straight away that you should go is it a balanced one? Yes, it is balanced, right? Why? Because you have 4 columns and 4 rows. So it is balanced. But the other thing that you have to see here is he's talking about what? His estimate of the production. His estimate of the production, which means this entire matrix talks about production. This entire matrix talks about production. Therefore, you would like to maximize your production or minimize your production. Obviously, maximize. So that's where the problem starts. Okay, chalo. Right, Nana? Okay, Nana, let's move on. Now, what I would like to do is, first of all, let's write what kind of a problem this is. Okay, just a second. Right, Anna. So, is it a maximization problem? Yes. So, it is a maximization problem. So, first, this maximization problem has to be converted into what? Minimization, correct? Huh? So, let's start the answer with that. This is a maximization problem. This is a maximization problem. So, first, it has to be converted into minimization problem, and then do other workings as done in the earlier problem. Okay, which means the last problem. So last problem, how we have done it, you have to do it the same way. Is that clear? So now the biggest question is how to convert a maximization problem into minimization. How to convert a maximization problem into minimization. It's pretty simple. What you have to do is, so let me write it over here. Take highest value in the entire matrix. Take highest value in the entire matrix and then reduce the entire matrix from that highest value. Is that clear? So which means you take the big number in the entire matrix and then reduce the entire matrix from that big number. Is that clear? Take the big number from that entire matrix and then reduce the entire matrix from that big number. For example, let's have a look into the question once. Let's have a look into the question, Anna. See here. If you look at this, what is a big number that you've got? 38, right? In the entire matrix. So from this 38, you have to reduce the whole matrix. For example, 38 minus 8, it will be 30. 38 minus 26, it will be 12. 38 minus 17, 21. 38 minus 11, 27. 38 minus 13, 25. 38 minus 28, 10. 38 minus 4, 34. 38 minus 26, 12. 38 minus 38 will be 0. 38 minus 19 is 19, 38 minus 18 is 20, 38 minus 15 is 23, 38 minus 19 is 19, 38 minus 26 is 12, 38 minus 24 is 14, and 38 minus 10 is 28. You got the point? So take the highest number in the whole matrix and then reduce the whole matrix from that big number. You'll be getting a revised matrix. Is that clear? Chalo. Now, So converted matrix. Converted matrix. Okay. 30, 12, 21, 27, 25, 10, 34, 12, 0, 19, 20, 23, 19, 12, 14, 28. Got the point, Anna? Right? So this is the converted matrix. Now, how did I do this? I just picked up the highest number from that particular matrix, which was 38, and from 38 I've reduced the whole matrix. Now I've got the converted matrix. Now please understand this converted matrix. Now this is a minimization problem. Now this is a minimization problem. Is that clear? And it is also what? Balanced. So which means, can I apply Hungarian method to solve this problem right now? Yes. Why? Because now it's a minimization matrix, because it's a converted matrix from maximization to minimization, and it is also balanced. So which means, can I apply the routine steps and can I solve the problem? The answer is absolutely yes. Is that clear? Right. Now that's very important. Now you can ask me, what was the logic behind this conversion? Okay. Let me do one thing. I'll write the original matrix also here. If you write the original matrix, that is the matrix which has been given in the question. Okay. If you write the original matrix over here, okay, let me get it. Right. Okay. Have a look into the original matrix. 8, 26, 17, 11. Okay. Just a second. 8, 26, 17, 11. Right? 8, 26, 17, 11. 13, 28, 4, 26. 13, 28, 4, 26. Next. 38, 19, 18, 15. 38, 19, 18, 15. 19, 26, 24, 10. 19, 26, 24, 10. Okay, right. Right, Nana. Now have a look into this particular matrix now. I'll change the ink color. Yeah. Now listen carefully. This is the original one, right? And this is the converted one. Now, converted one and original one will still give you the same answer. Try to understand the logic behind this conversion. For example, let's take this first row. Your objective is to maximize, correct? Because it is production. So your objective is to maximize the production, correct? Tell me, in the first row, you will select which one? 26. Correct? Yes. Whereas exactly look at the converted matrix in the first row. Now your objective with respect to the converted matrix is to what? Minimize. Correct? Tell me, if your target is to minimize, which one you will select from the first row? 12, because that is the least. Tell me, if your object is maximization, which one you will select from the second row? Second row, I would like to maximize. So I'll go for 28, which is the highest. Here, which is the least in the second row? 10. Here, which is the highest in the third row? 38. Here, which is the least in the third row? 0. Here, which is the highest in the fourth row? It is 26. Here, which is the least in the fourth row? It is 12. You see, both of them, they give same answers. Correct? That's the logic behind conversion. So whether you solve this problem as a maximization problem or you solve it as minimization problem, you'll get the same answer. But since we know that Hungarian method has got a limitation and this particular method can solve only minimization problems, therefore we have converted this original matrix into what, Nana? A minimization problem, yet it gives the same answer. That was the logic behind conversion. Yet it gives the same answer. That was the logic behind conversion. Is that clear? Right, sir. Having said that, okay. Now let's go for the minimization matrix. So what is the minimization matrix? You've got 30, 12, 21, 27, 25, 10, 34, 12, 0, 19, 20, 23, 19, 12, 14, 28. Okay, now first step, we have to do what, Nana? Row operation. I hope you guys remember this. So what do you mean by row operation? Select the least number from a particular row and then reduce it from the rest. Who is the least number here? 12. So 30 minus 12. It comes around 18. Okay, 12 minus 12, 0. 21 minus 12, 9. 27 minus 12, 15. Like that we'll do for the remaining. So it will be 15, 0, 24, 2. And here 0 is the least, correct? In the third row. So it's going to be the same, 0, 19, 20, 23. Coming on to the fourth row, it's going to be 12. So therefore 19 minus 12 is 7. You'll have 12 minus 12, 0, 2, 16. Okay, so with this we are done with what? Row operation. Now let's go for the next step. What is the next step, Nana? Column operation. What was the rules of column operation? Same. You select the least number from each and every column and then reduce it from the rest of the numbers in that column, correct? So in the first column you have 18, 15, 0, 7, correct? So which means it's gonna get repeated, 18, 15, 0, 7. Second column again 0 is there, so it will repeat. Third column, the least is 2, so it's gonna be 7, 22, 18 and 0, right, Nana? Now let's look at the fourth column. It's gonna be 2, so it will be 13, 0, 21, 14. Right, Nana? We are done with this. Now, once you are done with second step, in the third step, we need to what? What we have to do? We need to cover zeros with the minimum number of lines. So you got to cover zeros with minimum number of lines. Now, how to cover zeros with minimum number of lines? I already told you the rule. So what was the logical rule behind that? You need to cover zeros with minimum number of lines, means the logical rule was pretty simple. Select that row or that column which has got maximum number of zeros. Select that row or that column which has got maximum number of zeros. Now, applying the same logic, now you people tell me which is the row here which has got maximum number of zeros. Okay, let me change the ink color. I'll change the ink color. Okay, this should be fine. So first row you have 1, second row you have 2, third row you have 1, fourth row you have 2. So 2 rows with 2 zeros. Coming on to columns, 1, 3, 1 and 1. So I'll go with second column because it has got 3 zeros. Correct? Then what will I do? Check out the rows now. Second row has got 1 0, third row has got 1 0, fourth row has got 1 0. Is that clear? So now these three rows has got 1 1 0. Even if you look at columns also, first column has got 1 0, third column has got 1 0, fourth column has got 1 0. So either I can go with rows or I can go with what, Nana? Columns. Either you can do like this one, this one, this one, or you can go with rows also. Since I've started with columns, I went with columns. Okay. Therefore, now did I cover all the zeros? Yes. Did I cover it with minimum number of lines? Yes. Therefore, what was the rule, Nana? Is number of lines is equal to order of the matrix. Your answer is what? Yes. Why? Because number of lines is 4, order of the matrix is also 4 by 4. Therefore, it is yes. Once number of lines is equal to order of the matrix, we can proceed for what, Nana? Assignment. We can proceed for assignment. Pretty simple, right? So let's go to the assignment. So we'll be repeating the same step over here. 18, 0, 7, 13, 15, 0, 22, 0, 0, 19, 18, 21, 7, 0, 0, 14. This was our earlier matrix, right? Now, remember the rules which I've told you. Okay, what did I tell you? When it comes to assignment step, when it comes to what, Nana? Assignment step, I told you that select that row or that column which has got one single zero. When it comes to covering zeros with minimum number of lines, I told you that select that row or that column which has got maximum number of zeros. Here it is exactly opposite. Select that row or that column which has got one single zero. So first row, I've got one zero, so I will assign. This 0 and this 0 gets cancelled because it was in the same column, right? Second row, now I've got only one 0, so it will be assigned. You don't have any zeros in this column or in this row. Okay, in this column or in this row. Third row also I've got only one 0, so I'll assign. Fourth row also I've got only one 0, I will assign. Is that clear? So which means what's gonna be your final solution? So your final solution will be task will be the first column, subordinate will be the next column, production will be the next column. Okay. Now, task 1 is given to subordinate 2, correct? Here, this is task 1 which is given to subordinate 2. Okay. Task 2 is given to subordinate 4. Task 2 is given to subordinate 4, correct? Task 3 is given to subordinate 1. Task 3 is given to subordinate 1. Next, task 4 is given to subordinate 3. Here, task 4 is given to subordinate 3. Is that clear? Production, you have to pick these numbers from original matrix and not the converted matrix. This is very important. You got it? Why did we convert? Only for our convenience of solving. So you have to pick up the numbers from the original matrix, not from the converted one. Is that clear? So if you pick the numbers from the original matrix, it's going to be what? So it's gonna be 26 here, 26, 38, 24. So your answer is going to be 114. Your answer is going to be 114. Is that clear? So finally, this is your maximum production possible in the given scenario. Is that clear, guys? So I hope it's pretty easy to understand. If you have a little bit of confusion with respect to assignment step and covering zeros with new number of lines, you can watch it again, because anyway multiple views are possible. You can watch it again and you can get clarity. Still, if you have any doubt, you have my WhatsApp number. You can just message me and I'll clarify your doubts. Is that clear, guys? Right. So with this, we'll finish off this particular video. Thank you, guys.